My name is Sergi Aliaga, and I'm a wireless systems engineer here at Northeastern. I'm currently on my 4th year of my PhD, working with Professor Josep Jornet at the ultra-broadband nano-networking laboratory. And my research is specifically focused on enabling ultra-broadband wireless communications for space applications.
And my name is Hussam Abdellatif. I'm a 5th year PhD student here at Northeastern, and I work under the same professor in the same lab group, but I do something a little different. I work with hardware architecture and digital design for processing high-speed kind of communication mechanisms. So in terms of what I do is, a big aspect of the technology we're trying to pursue, which is the terahertz kind of technology, is it offers multi-gigahertz of bandwidth. And what that really means is you can talk really, really fast in the analog domain. But the thing is, when you go to your computer and your handheld devices like your phone, you need to also process really, really fast. And a lot of the time, we haven't been able to figure out how do we process this much data at a really, really fast pace. And the data we're talking about is relatively 50 to 100, 150 gigabits per second and pushing towards terabits per second. So that's like incoming and outgoing at very, very high speeds. And what I do is figure out how to design systems and hardware architectures to handle these speeds. So we use state-of-the-art hardware like the one in front of me and the other one here. And we tried to figure out how to do that. And we came up with a few ideas. And one of those ideas actually got patented through Northeastern. In terms of what it will impact society, we're hoping that at some point we reach a place where we can deploy this technology where you can send very, very massive files and data really fast at that kind of rate of hundreds of gigabits per second.
All that he said can maybe be summarized in the fact that he builds very fast radios, super fast, and I use them to put them on satellites and make satellites talk fast, right? And what we have here in front of us is the components of those radios. In the end, the radio is a device that converts ones and zeros into electromagnetic waves that get out, travel through the air, and get converted back to ones and zeros in another radio, which is the receiver, right? So what we have here is basically the components that allow you to do that. Your computer would connect, or phone or whatever would connect to a board like this one and give it ones and zeros. This guy would pass those ones and zeros to this guy, and this guy would convert it into EM radiation and output it through this antenna here. My work is, as I was saying, putting these radios in space. So I spent the first 3 years of my PhD seeing if it made sense. Actually, do we need such fast radios for space communications? What would be the benefits? What would be the opportunities? And what would be the challenges of doing that? And during those 3 first years, as Hussam was saying, we got very, very exciting results. We've got very good ideas. We've tested them. We've patented them. We've gotten a lot of awards. And what's most exciting of it all is that we're now ready to do that experimentally. Or in other words, we're going to actually build a tiny satellite to put all of this put together and in a very compact form in a tiny satellite and put it out there in space. So that we believe it's super, super exciting, and it can have a very, very important impact in society. By putting our technology on board a satellite, what we are allowing is, on the one hand, having more speed, so enabling faster data rate applications from satellites, has high-speed internet, for instance, but also more bandwidth. That means putting more users, serving more users. With the same radio, we can now use 10, 100, 1,000 times more people than what current radios allow for.
When it comes to Northeastern, they have a kind of a massive advantage compared to industry and academia, which is their industry partners, first of all. They have a variety of different industry partners they love to collaborate with us and work with us side by side to advance the technology that we're working on. In fact, this over here was manufactured by Keysight, one of the most pioneering hardware companies at the moment. And it roughly costs $200,000 to $250,000. So it's the state-of-the-art hardware technology. And instead of buying it from them, they kind of loaned it to us to work on it and to kind of experiment on terahertz communication. So that's kind of a main advantage, the collaborations that we get, whether it's from industry or academia. The second part is the collaboration with academia. In fact, a lot of this stuff that we have built, we didn't have the expertise to build the hardware architecture. But through our collaborations with Florida Institute and other universities, we kind of collaborated and worked and brainstormed and came up with some of the ideas to build on top of these hardwares. So that's like one of my kind of favorite aspects, the collaboration. The second is the laboratories we have here are kind of cutting edge. The equipment we use, the funding we have, it kind of facilitates this kind of push and research and allows us to be flexible and comfortable with what we do. And in terms of asking for resources, they're always at our disposal, which kind of Northeastern has been amazing at and been delivering throughout at least my PhD.
No, I mean, adding on what he said, I think in terms of working at Northeastern, I think the most amazing thing of working here is the resources, as Hussam was saying, the resources and collaboration. We can maybe do a cost rundown of how much all of this costs, but it gets very, very high. And I don't think we would be able to work with such high quality hardware and high quality partnerships if we were at other universities. So I think this is one of the more stronger points at Northeastern, I would say.